It spots the fish from 200 meters up, not the fish breaking the surface, not a splash or a ripple indicating something below. The fish itself, swimming beneath the water, visible through the reflection and the refraction and the glare that makes fish invisible to human eyes at that distance and altitude. The bald eagle sees it, adjusts its angle, folds its wings into a partial stoop, and hits the water at roughly 80 kilometers per hour with its talons extended, entering the surface feet first, closing its talons on the fish with a grip pressure of approximately 150 pounds per square inch, and hauling the fish, which may weigh as much as half the eagle's own body weight, out of the water and into the air in a single continuous motion. The whole sequence, from the moment of locking onto the fish to the moment of clearing the water with the fish secured, takes approximately 1 second. There are few animals anywhere on Earth for which the word spectacular is genuinely insufficient. The bald eagle is one of them, and the reasons go considerably deeper than the white head and the yellow beak and the 7-foot wingspan that make it one of the most recognizable animals in North America. The bald eagle is an engineering achievement of the first order, a sensory system of extraordinary sophistication, and a conservation story that is one of the most remarkable reversals in the history of wildlife management. This is the full account of what it is actually like to be one. The eyes first, because the eyes are the foundation of everything the bald eagle does. A bald eagle's eye is approximately the same size as a human eye. The eagle itself weighs between 3 and 6 kilograms. This means the eagle is carrying eyes that are proportionally enormous relative to its body mass. If human eyes were proportionally as large as an eagle's, they would be the size of billiard balls. The size matters because larger eyes gather more light and support larger retinas with more photoreceptor cells, which translates directly into visual acuity. The bald eagle's visual acuity is approximately 4 to 8 times greater than a human's. The human standard for normal vision is the ability to resolve a feature at 1 arcminute of visual angle. The bald eagle can resolve features at approximately 1/4 of 1 arcminute. This means the eagle can see, with the clarity that a human sees at 10 meters, objects that are 40 to 60 meters away. The fish 200 meters below is, to the eagle, approximately as visible as a fish 25 meters from a human standing at the water's edge. The eagle's retina has 2 foveae, 2 zones of maximum photoreceptor density, rather than the single fovea of the human eye. One fovea provides the forward-facing, binocular high-acuity vision used for precise targeting of prey. The other provides lateral high-acuity vision for detecting movement in the periphery. The eagle can simultaneously maintain high-resolution attention on a target directly ahead and high-resolution attention on what is happening to its sides, a dual-focus capability that no human optical system has replicated. The eye also contains a pecten oculi, a comb-like structure projecting into the vitreous humor of the eye from the retina, which is thought to provide nutrients to the retina and may also enhance the detection of motion by creating a shadow pattern on the photoreceptors that moving objects disturb. The exact function of the pecten is not fully resolved by science, but its presence in eagles and other raptors suggests it serves a specific function in the visual system of high-performance aerial predators. The talons that execute the fishing strike are the eagle's primary weapon and one of its most impressive physical features. Each talon is a curved, hardened keratin structure growing from the toe, similar in composition to a human fingernail, but enormously stronger and sharper. The gripping strength of the bald eagle's feet is extraordinary. The grip closes with a force of approximately 150 to 200 pounds per square inch, a pressure sufficient to pierce through the scales and flesh of most fish immediately upon contact, ensuring that the fish is secured before the eagle needs to exert the sustained effort of lifting it from the water. The hallux talon, the rear-facing talon that functions as the primary killing structure, is the longest and the strongest, designed to drive through the spine of the prey and prevent escape. The grip is maintained not by continuous muscular effort, but by a locking mechanism in the tendon of the toe, a ratchet-like arrangement that keeps the talon closed under load without requiring the eagle to actively squeeze. This means the eagle can maintain its grip on a struggling fish during the entire flight back to the nest without fatiguing the foot muscles that would otherwise be required to hold continuously. The wings that carry all of this are designed for sustained soaring rather than for the powered flight that smaller raptors use. The bald eagle's wingspan of between 1.8 and 2.3 meters generates lift through a combination of the wing's shape, the cross-sectional profile that produces lower pressure above the wing than below, and the wings area, which is large enough that the eagle can stay aloft on thermal updraft for hours with almost no wing flapping, riding the columns of rising warm air that develop over sun-heated land surfaces on clear days. The soaring ability is directly connected to the eagle's hunting strategy. An eagle that can cover large areas of water and shoreline by soaring on thermals, searching for fish near the surface, is an eagle that is spending very little energy on the search phase of hunting. It is cruising at altitude, riding free energy from the sun-heated atmosphere, scanning the water below with those extraordinary eyes, waiting for an opportunity that requires rapid committed action, but that costs almost nothing to wait for. This energetic efficiency is one of the bald eagle's defining ecological advantages. A bird that can spend hours searching from altitude without significant energy expenditure, then commit explosive energy to a single strike, is a bird that can afford to be selective, that can wait for the highest probability strike rather than committing to lower probability attempts that waste energy and risk injury. The eagle that soars for 3 hours and makes one successful strike has used less total energy than a bird that makes 6 unsuccessful powered flight hunting attempts in the same period. The nest, called an eyrie, is the bald eagle's most visible non-hunting achievement and one of the most impressive constructed objects in North American wildlife. Bald eagles mate for life and return to the same nest site year after year, adding material to the existing structure with each breeding season. A bald eagle nest that has been in continuous use for several decades can reach dimensions that seem impossible for a bird-built structure, up to 3 meters in diameter, up to 6 meters deep, and weighing up to a ton. The largest bald eagle nest on record, in St. Petersburg, Florida, measured nearly 3 meters across and nearly 6 meters deep and weighed an estimated 2,000 kilograms. The nest is built from sticks, arranged and interlocked with a structural intelligence that produces a platform strong enough to support the adults, the eggs, and eventually the eaglets through months of intensive use and the variable stresses of wind and weather. The inner cup of the nest is lined with softer materials, grass, moss, feathers, pine needles, providing insulation for the eggs during incubation and cushioning for the chicks during their first weeks of life. Both parents participate in nest construction, incubation, and the feeding of the young. The incubation period is approximately 35 days, during which the parents take turns sitting on the eggs, maintaining the temperature necessary for development and defending the nest from potential predators. The commitment to shared parenting that bald eagles demonstrate across the breeding season is one of the more striking features of their social behavior. A mating pair that has established a productive territory and a successful nest site will maintain that partnership across many breeding seasons. The accumulated experience of the pair producing progressively higher success rates than newly formed pairs achieve. The eaglets hatch helpless, covered in gray down, entirely dependent on their parents for food and thermoregulation. They grow rapidly, consuming the fish and other food that their parents bring to the nest, adding body mass, and developing the flight feathers that will eventually support them. The first flight, attempted at approximately 10 to 12 weeks of age, is one of the more dramatic developmental events in bird biology. A bird that has never been airborne jumping from a platform 6 meters up in the canopy, committing to a physical process it has never executed before, powered by instincts that have been refined across millions of years of eagle evolution, and that produce, in most cases, a controlled first flight, even in a bird that has had no practice. Not all first flights are successful. Young eagles miscalculate, hit branches, land badly. The parents continue to feed them for several weeks after fledging, supplementing the young bird's initially erratic hunting attempts until the young eagle has developed enough skill to reliably feed itself. The full development of adult hunting proficiency takes years. Young bald eagles, identifiable by their mottled brown plumage before the white head and tail develop at approximately 5 years of age, are less efficient hunters than adults and suffer higher mortality rates in the first years of independent life. The bald eagle's relationship with human beings across North American history has been one of the more dramatic reversals in the record of wildlife and conservation. The eagle was present across the continent in large numbers when European colonization began, estimated at somewhere between 300,000 and 500,000 individuals. By 1963, the population in the lower 48 states had fallen to 417 known breeding pairs. The cause was a combination of habitat loss, direct persecution. Bald eagles were shot for decades, particularly in Alaska, where bounties were paid for eagle feet on the mistaken belief that eagles were a significant threat to salmon populations, and the catastrophic effect of DDT, the pesticide that entered aquatic food chains in the mid-20th century, accumulated in fish, and was ingested by eagles that ate the fish, causing eggshell thinning so severe that the eggs cracked under the weight of the incubating parent. DDT was banned in the United States in 1972. The Bald Eagle Protection Act had been in place since 1940. The eagle was listed as endangered under the Endangered Species Act. The recovery program that followed was one of the most sustained and eventually most successful conservation efforts in American wildlife management history. By 2007, the bald eagle was removed from the endangered species list. By 2023, the population in the lower 48 states had recovered to an estimated 316,700 individuals, from 417 breeding pairs to over 300,000 individuals in 60 years. This is not a small achievement. This is one of the most significant recoveries of a large bird species in recorded conservation history. And it happened because a specific pesticide was banned, a specific legal protection was maintained, and the underlying habitat, the rivers, the lakes, the coastlines where eagles hunt, was sufficiently preserved to support the recovery. The bald eagle is back. It is fishing the rivers. It is building its enormous nests in the tall trees above the water. It is soaring on thermals above the lakes, those extraordinary eyes scanning the surface below, waiting for the fish to break into visibility. When it sees it, it will fold its wings and drop. 1 second later, it will be climbing with breakfast. That is the whole of what it is to be a bald eagle, and it is by every available measure extraordinary.